Hi everyone. So in today's video, I am going to go over this paper titled Evaluation Report on MCP Servers by Ziling Luo, Xiaorong Shi, Xuanrui Lin, and Jinyang Wao. I'm greatly sorry if I mispronounce any of those names. And this is, I believe, work by Alibaba, given this email address. And this is also a fairly fresh paper from April this year. Let me just double check if things are being recorded well. It seems they are. All right. So, yeah, I've recently gotten interested in MCP servers. I recently read like this other paper, which I found really nice on to get like an overview on the MCP landscape. This so if you're interested, I would recommend checking it out. I thought might as well record myself, my first thoughts on stuff and all of that. This is similar to how I've been recording for a while. I've also been gone for a while. Life happened. Yeah, it's hard to consistently upload. I'll try to upload a bit more frequently, but I can't make any promises on it. So, the executive summary. There are significant differences in effectiveness and efficiency among MCP servers. Using MCPs does not demonstrate a noticeable improvement compared to function call. All right, which I believe is like one of the main reasons for people to use MCP servers. The effectiveness of the MCP server can be enhanced by optimizing the parameters that need to be constructed by the LLM. What does it mean to enhance it? Maybe, yeah, the paper will tell us. All right. So, the introduction. MCP Model Context Protocol is an open protocol that enables AI models to securely interact with local and remote resources through standardized server implementations. Thousands of MCPs have been proposed in recent months. At the same time, several model platforms like OpenAI and Alibaba Cloud announced the support of MCP in their LLM products. The outbreak of the MCP protocol has become a reality. And if you're not familiar with the MCP protocol, it's just like a way or a protocol which defines a generic setup which can be used to connect LLMs to tools. So earlier you would have like very specific code for connecting your LLM to a product like Google Docs. But with MCP servers, you have like one generic interface which can be used to connect your LLM to any tool, as long as both the tool and as long as the tool has an MCP server. All right. So to study the effectiveness and efficiency of MCP servers, we selected several widely used MCP servers and conducted an experiment to evaluate them using MCP Bench on their accuracy, time, and token usage. We focus on two tasks, web search and database search, fairly standard tasks. The former involves searching the internet to answer questions, while the latter entails fetching data from a database. I'm assuming both of them will have like some form of query formulation. However, this might be like a SQL query formulation. All MCP servers were compared using the same LLM and prompt in a controlled environment. We aim to answer the following questions. Are MCP servers effective and efficient? Does using MCP provide higher accuracy? And how to enhance the performance? So they create MCP bench, which they release right here. Really cool. Oh yeah, I think I already started this when I was going through and selecting this paper to read. Okay. Yeah, besides we provide a data set of web search and database search at the same time. All right, really cool. So tasks and dataset. MCPs encompass several tasks, including computing, memory management, web searching, and database interaction. They can be categorized into two groups. So you have data fetching tasks. This group retrieves data from various sources to assist LLMs in completing tasks. The effectiveness of these MCPs is determined by the accuracy of data fetched. Okay, so yeah, this is just like the retrieval abilities by like doing open-ended search, I guess. And then world changing. These MCPs alter the state of the world. Their effectiveness hinges on whether the state has been successfully modified. Like you can have GitHub MCPs that can commit code that changes the data in a GitHub dataset. Okay, makes sense. So data fetching and world changing. Evaluating world changing MCPs presents challenges due to difficulty in assessing the underlying status of the data sources. Therefore, we focus will be on data fetching tasks, specifically on two tasks. Okay, so they're totally skipping fold changing. I can see the argument for it being hard to evaluate, but I also think that if you're going to do like an evaluation report on MCP servers and you skip like the most interesting part where these MCPs actually exhibit their agency, uh, that might not be the best. All right. So, yeah, the first thing is web search. The task takes a question as input. The LLM rewrites it into keywords or some short sentences involving a tool that typically searches the internet and returns results to the LLMs. So, an example with the Brave search MCP is in table one. So, what is the middle name of Barack Obama? You perform a search using this tool, and the query is middle name of Barack Obama, and the result is Hussein. Okay. To eliminate biases in the dataset, we introduce multiple data sources encompassing both Chinese and English languages across various fields. Um, okay, I think, yeah, this is the data source. So you have frames, which is an open source dataset, 100 examples. I'm not sure if this is supposed to be an example. I guess a case is just an example. As of August 1, 2024, which country hosted the FIFA World Cup last? And hosted the FIFA World Cup the last time. The UEFA Champions League was won by a club from London. Okay, so this is like a two-hop question. First, you need to figure out what which which London club won UEFA Champions League last, and then figure out the year, and then also do this. All right. You also have Chinese news, gleaning data from daily when Kianbo. I'm really sorry for this. Not that transcript over the past 3 months, and then you also have knowledge in Chinese. Okay, so it's 100 samples of English, 200 in Chinese. I don't really. I guess these are translations then. Okay, database search. Database search or database interaction is the data table task with database. Okay, this task takes a question. The LLM retrieves data through a database MCP. Table 3 shows an example involving the MySQL MCP, and they have data from various sources. Okay, let's jump to table 3. You need to fetch the sales of Tesla Model S since 2025-01. So you're going to execute SQL, and then you're going to perform the following query. The query is select sum of the sales column from this is should be the table, right? Sales is the table name, I guess, where the series is this and date time is this. Okay, yeah, this is like I guess typical SQL. And then I'm always a bit scared about like these kinds of open-ended. Uh, give your LLM access to your DB, but I assume that if you set up your permissions correctly, which I don't think a lot of people do, but if you do it, it should be fine. If you don't, then things can be catastrophic if your executed query just overwrites your database or dumps your database or something. Okay, so the data source of database search task, we have car by a synthetic data set from an automobile manufacturer data source. Okay, and then SQL eval, which is sampled from SQL eval. It is based off the schema from the spider. I think spider is like a popular knowledge graph, if I'm not wrong, but with new set of hand selected questions and categories. Uh, okay, which authors have written publication in both the domain machine learning and the domain data science, and Ashish Vaswan. I mean, hmm, maybe it's a data set biasing, but I would assume there's like millions. Millions might be a big word, but at least several tens of thousands of people. Yes, and the other thing is that I don't really know how do you distinguish because most ML papers have like some exploratory data science phase, but yeah, whatever. All right. So now the MCP servers that they use, they collected from GitHub and Smithery. I've heard a lot about Smithery. Let me quickly check what's. Okay, so this is like a place where you can find MCP servers. Ah, pretty cool. Okay. So due to limitation of time and cost, we selected those having more call records at April 2025. Okay, fair. So they have Brave Search, then they have DuckDuckGo Search, they have Tavily MCP server, uh, powered by Tavily. Okay, is Tavily a search engine? I think I've heard the name, but I'm not quite sure what it does. Hmm. Okay. So it's like a search thing specifically for agents. X I've heard, X I've seen, very cool. Firewall search, Bing, Booka AI, a search engine for AI that provides access to high quality global knowledge from nearly 10 billion web pages. Okay. And then you have web search related function calls. Uh, okay, so this is to do a contrast with these were the MCP server. The other way is like you do a function call where you don't have like a generic interface which you get with MCPs. So you have Qwen Web Search, which uses the SDK provided by Qwen Max this to enable online search. I guess this is like API calls. And Quark Search, an AI search engine that is particularly useful for searching unknown information such as weather, exchange rates, and current events. This is also by Alibaba. Okay. And then for database related stuff, they have Xi'an MCP server, an MCP server that supports data retrieval from a DB using NLP, okay, natural language queries. So I'm assuming that Xi'an SQL is like this MCP server takes your query, writes SQL, and then yeah, it's a text to SQL LLM. MySQL MCP, okay, and PostgreSQL MCP, PostgreSQL MCP. Okay. Now for evaluation, accuracy is evaluated to demand correctness. It is assessed by an LLM-based grader. So they use DeepSeek V3 uh, as the grader. The prompt is for the following question. Please judge whether the predicted answer is correct. It is considered correct if it addresses the key information. Okay. The accuracy is 1 or 0. The overall accuracy is the average. Okay. Nevertheless, issues such as network disruption, API key limitation, and program crashes prevent the complete retrieval of every sample. Consequently, we consider another criteria, accuracy of valid samples. I mean, shouldn't you only do this? Like, why would you also include failure cases? Like, I can support, uh, I can get behind things where it's an innocuous query, but it still gets blocked, and then you're effectively judging like the MCP server itself. But if you want to compare the efficiency, then I don't think. Yeah, let's go ahead. Valid samples are those that successfully complete. Time consumption is end-to-end latency. I assume this is also like hyper dependent on. Yeah. Sorry. Let me pause for a bit. Uh, yeah, I think I got a call and had to pause it for far too long. But yeah, let's go back. So I guess we discussed like there could be some potential issues with measuring time consumption. It would be hardware dependent and whatnot. Token consumption is they record the pre-fill prompt, completion tokens, okay, and then other setups. Okay, this was executed in Singapore with this CPU and RAM config. I'm assuming like this is a VM they set up because no one is buying dual core CPUs with 2 GB RAM setups. The evaluation framework uses MCP bench. All MCP servers except DuckDuckGo are launched on the server in SSE mode. The timeout is set to 30 seconds. The system prompt is as follows. We collect the query from web search and send it in. They said as follows, and then I don't think they uh, added it. Handles questions that may require web searching. Input contains this output. The question pass searches check results. Output can either be output in this form or the direct answer. The example input question was the current president. If no search has been conducted, you do the search. If this is there, then you say Joe Biden. But yeah, this is also incorrect given the timing of display. For the database search, they use MySQL database and Postgres, these versions. Okay, let's get into it. Are MCP servers effective and efficient? So if you look at accuracy numbers, These are all MCPs. Okay, the difference in effectiveness are significant based on the accuracy of valid samples. The highest accuracy is observed with Bing web search. Yes, and DuckDuckGo has the lowest, which is only around 10%. And okay, this is for the same task. The difference in efficiency are even more pronounced. Uh, the fastest are Bing web search and Brave search, which you need less than 15 seconds. Exa takes 231 seconds. Note that valid samples are cases of normal returns without timeout, so this value is unaffected by timeouts. Okay, so this is, I think, only for valid samples. Token consumption is similar based on the number of tokens. For valid samples, consumption generally falls between 150 and 250 tokens, indicating that model consistently provide concise answers. The pre-filled token consumption is quite different though. It's like 5,800 tokens. I'm assuming that this has like a very big prompt or something. Does MCP provide higher accuracy compared to function calls? They again do this. The results are shown in figure 1 and table 6. We observe that both function call and tool usage exhibit competitive accuracy. The accuracy of coin web search is this, surpassing XR DuckDuckGo tab entry. Quite surprised about X actually. I would pretty. So one caveat you have with a lot of these studies is it's very implementation specific. Like they're not implementing the MCPs themselves, but I'm assuming you could implement MCPs in a much better way. This is my toxic trait. Uh, there is not much difference of time consumption and compared to MCP service. Okay, so if you look at accuracy, the function calls are towards the higher end, and they also have like lower uh, time consumption. Yeah, okay, and of course, lower token usage. How to enhance the performance? To address this question, we consider database of stars. The MySQL MCP server implements a straightforward encapsulation. After configuring the DB with these details, MCP establishes a persistent connection and exposes the tool. When calling this tool, the model must construct a query parameter that must be an executable SQL statement. Although this simple encapsulation functions as an MCP, the sign is the most challenging part of the process, constructing the SQL query statement to the LLM. Consequently, the success of this entire thing relies on the LLM's ability. So they introduce a declarative interface. The key idea is to replace the structural parameter of MCP by a declarative interface. So, okay, you use natural language as the interface, and then this MCP server uh, just convert builds on top of encoder to convert natural language into SQL before executing comparable to the okay. And these are shown in table 7. By adding this, it improves accuracy by 2%. And in PostgreSQL experiment, this results in a 22-point increase. So you have MySQL MCP server, you get 54% accuracy. And if you use the natural language interface with the text to SQL conversion, you get 56% accuracy. And you also have hmm, like a much smaller prompt time actually, which is why this falls. And with Postgres, okay, this is like a significant jump. Really cool. So this is what I really like. This shows that having like workflows where you have specialized routes, like specialized subroutines or specialized models for some subroutines can significantly push your performance. If I had to have one takeaway from the paper, this would be like one of the main takeaways. Now, case studies. Web search tasks. For the web search tasks, we evaluate the search performance of Brave, Boca, and Quinn web search using the frames dataset. The example is shown in figure 2. To ensure aesthetic consistency, the returned results were processed by removing HTML tags and truncating long outputs. Comprehensive information is okay. So your question is, I'm thinking of a movie where Hans Zimmer won a Grammy Award for his work. He won the Grammy Award the same year that he did his first musical score for film director Michael Bay. Can you please tell me the name of the movie? The ground to transition. Crimson Tide, and the search queries Hans Zimmer Grammy Award Michael Bay for collaboration. Okay, this is like very keyword searchy. Brave search provides the top 10 relevant Wikipedia pages, including the title, description, URL. For clarity, only one of the pages is displayed. It includes the ground truth. Nevertheless, the lack of detailed description impedes LM's ability to effectively link the question to the pertinent result. This forces LM to solely rely on its internal knowledge, leading to an incorrect response. So you have the fact that he won 4 Grammy Awards, two for Lion King, one for Crimson Tide, and one for The Dark Knight. But you don't have the other information in the same page. Okay, based on this thing, and he say the LM says The Rock. Boca summarized the search results and explicitly informed the LM that the correct answer was Crimson Tide. Hans Zimmer is a renowned master of film scores. Uh, and okay, the MCP says that Crimson Tide is indeed the first round work. When web search also attempted to analyze and summarize the results, however, it produced an incorrect result. Uh, okay, it says The Rock. In summary, the search results returned by web search related MCP servers and web search related function called directly influenced whether LLM can accurately answer a given question. And search results are provided without any processing. LLMs must depend solely on their reasoning abilities. On the other hand, when the results are analyzed and processed before return, LLM can more easily obtain answers. Now, database search tasks. For database search tasks, we evaluate the search performance of PostgreSQL MCP server and Shian MCP server using this. So, okay, now there are some examples. Question is how many publications were between these years? Ground truth is 5. The PostgreSQL MCP server operates by sending a SQL query generated by LLM in response to a specific query. Question, the SQL query is executed and then output is returned. Subsequently, the LM utilizes the database query results to formulate the final answer. So the query you get is select count star from publication where year it is. You get this response and then, okay. With Shian, what you get is the search query, which is the natural language thing. Then you first convert it to some intermediate representation which you don't show. You get this as response, and then after implementing or executing that query and whatever post processing the MCP server does, and then you get this response. Okay. So the conclusion evaluation of various MCP servers highlights significant differences in efficiency and effectiveness. MCPs have like structured tool usage, do not offer demonstrated marked improvements. Bing web search achieved an accuracy of 64%, where DuckDuckGo was only at 10%. Furthermore, performance varied widely in terms of time consumption, with top performers doing stuff in only 15 seconds, while X being very slow. Okay, these are very interesting takeaways. Importantly, we found that the accuracy of MCP servers can be substantially enhanced by optimizing the parameters that LLMs must construct, which is like the Srihan example. Overall, the MCPs provide a structured means for AI tools to interact with data. There remains considerable potential for optimization by addressing the challenges LLMs encounter in parameter construction, enhancing the user friendliness of tool interfaces. Developers can significantly improve the performance and reliability. Okay, yeah, very cool stuff. Now, let me quickly see the appendix. This is more about the data set. These are some examples of, I guess, this is the DDL information, and then these are some more, I guess, fleshed out examples. All right, yeah, this is pretty cool. Yeah, if you like the video, feel free to let me know what are the things you want me to cover. At some point, I did cover DeepSeek earlier this year, and I have like this reading list of uh, reasoning models which I might go over at like at the same time. Just have like a 4 or 5 hour video where I read through all of these. I don't think that would be enough, but yeah, that is all from my side. See you guys next time.